to write down that definition of a compound inequality. A compound inequality is a pair of inequalities joined by the words and, or. In an and inequality, you don't have to see the word and. You must see the word or in an or inequality. So it would be easy to distinguish whether something's an and or an or. If you don't see a word, then it has to be an and. In the example, first example, solve and graph the compound inequality. 3x minus 1 is greater than negative 28 and 2x plus 7 is less than 19. So what you do when it's separated, most of the time you'll see and inequalities put together as one big inequality, like this right here. You won't actually see the word and. Okay, but you know this is an and inequality. Yes?
Is that negative 18?
That is negative 28.
Okay.
Alright, so to solve the first one, you would add 1 to both sides. You would know what 3x is greater than negative 27, and then you would divide by 3 to get x is greater than negative 9. And to solve the second part of it, you subtract 7, 2x is less than 12, divide by 2, x is less than 6. And then for the graphing part of it, you graph each of them separately. So for x is greater than negative 9, we know it's an open circle on negative 9. And you always, on the number line, when you have a compound inequality, make sure you're working correctly on the number line. The numbers go from least to greatest on a number line. So negative 9 we know has to go on this side, 6 has to go on that side. So put the negative 9, you would put an open circle on negative 9, and you would shade to the right of that. And, the word and means your solution set, your graphical solution set, must work for both inequalities. That's why it's an and. Or means it only has to work with one of the two. Alright, so right now, I'm shading to the right of negative 9. Now I'll come over here and graph this, open circle on 6, and I shade to the left because this x is less than 6. Alright, so which region works for both of them? The one in the middle. So your final answer is here. Okay? You wouldn't go beyond here because that wouldn't make sense. If we get to negative 10 wouldn't work right here, would it?
No.
And I said it had to work for both since it was an and. If I got to 7, 7 wouldn't work for here. Alright, so this is your answer right here. Okay? This is how you would write your answer. This is your graphical representation of your answer. This is another way that you could write an and inequality. This and inequality. Negative 9 is less than x, which is less than 6. This is the more common way that you will see it throughout this book. Good. Now let's look at an or. Solve and graph. Or means it only has to work in one of the two when you graph it. So again, you graph or you solve each of them separately. You add 2 to the first one. You know what 4y is greater than or equal to 16. Then you divide by 4. So y must be greater than or equal to 4. Next one, add 4. 3y is less than or equal to negative 9. And then divide by 3. So y is less than or equal to negative 3. So your solution is y is greater than or equal to 4, or y is less than or equal to negative 3. So again, I graph each of them separately. Make sure you put the negative 3 first, because that's the smaller of the two numbers. Yes?
Can you go over one more time how to graph them?
Yeah.
I'm not sure All
right, so I'm graphing this one first. because that's the smaller number, okay? Y is less than or equal to. Equal to sign means you have to close your circle to include the negative 3. That's part of your solution. Less than means what numbers are less than negative 3. Everything to the left. So that's why I shade to the left. Then I go over here to the 4. Greater than or equal to, since it's an equal to sign, closed circle. What's greater than 4? Everything to the right. So everything to the right of 4 or the left of 3 will be a solution to the original problem. Because remember, the solution only has to work in one of the two because it's an OR. Okay? So that's what your graph should look like. All right?